All right, so what we end up having is we have ourselves a metal and a non-metal. Metals, we already said, are elements that tend to lose their electrons because their ionization energy is really low. And non-metals tend to gain electrons because their ionization energies are high, so their electrons don't get taken away, but their electronegativities are also high. So they have the ability to take electrons away from the metals. So if a metal and a non-metal come together, we end up getting ourselves the non-metal gaining an electron from the metal becoming a positively charged cation, and the non-metal becoming a negatively charged anion. What we end up then getting is what we call an ionic bond. An ionic bond. And so what basically that means is we have a positive, negative attractive force between two opposite charges. And of course, what we end up getting with that is we get ourselves a positive charge and a negative charge. As they attract to each other, they create an ionic bond. It's a very, very tough bond. But when it comes together with another pair of positive negative charges, of course it doesn't have to be a pair, it could be any numbers of them, but it comes together, it'll be just as attracted to this negative charge as it is to the one that it originally joined with. And then we get another one, and another one, and another one, and another one. You can start seeing a regular repeating pattern. And this regular repeating pattern, we say, is starting to form a crystal. So that is a crystal. And what we say is that a regular repeating pattern forms what we call a lattice. A lattice. So a lattice is like I typically think about what you put on the side of your house, like roses grow on and whatnot. It's a regular repeating pattern, it's a lattice work, but this is a lattice. Now, with that being said, we have ourselves these particles that were moving around, and then all of a sudden now they're moving around, they get locked in place, they're moving around, they get locked in place, these guys are moving around, they get locked in place. Well, all this kinetic movement energy has got to go somewhere. And where does it go? Well, it leaves the system. It leaves the system. When things go from a higher state of entropy to a lower state of entropy, that means they move from a greater state of movement to a lesser state of movement. That kinetic energy loss has to go somewhere, and it leaves the system. And the amount of energy that's released when these bonds are formed is what we call the lattice energy. It's the lattice energy. And it's not really that big of a deal, but typically when these ions form these solids, they release that energy. And of course, that is also the energy you got to put in to break them apart again. So it's talking about sometimes the lattice energy being the energy that's released when these bonds are formed. And it's also the energy that is going to be needed to break it back into its ions again. Now, when it comes to this, typically ionic bonds, we almost always see them as solids because we have a lot of really strong forces and we have them in this regular repeating crystal-like pattern. So they're not acting as liquids, they're not acting as gases. They typically are gonna have higher vaporization points, they're gonna have higher melting points than a lot of your covalents. And so we see kind of some of those trends there. One of the things we do see is that these guys, when put into water can dissociate them. Water can dissociate them. So associate, to hang out together, disassociate, you break apart. What is happening is water with its polar molecules, you guys who have me in class know, positive charge, negative charge. Water coheses to itself, freely moving around. But then the positive side of water, which we're gonna come back to when we do Vesper, talk about why it's polar, etc., is gonna come over. So imagine if this is an ionic compound, this is the negative side, this is the positive side. Water, this gets dropped into water, water comes by, positive side attracts to the negative side. Negative side, the oxygen, is gonna attract to the positive side. And then not only are they attracted to these sides, but they're also attracted to all these other, they have the cohesive attractive forces with all the other waters. As a gang, water grabbing onto the sides of the ion, the positive, negative sides of the ion, and grabbing onto all the other waters are moving around. And what eventually it does is it causes these guys possibly to break apart and to dissociate into their ions. And so what we say is that when we put ions into water, they can dissociate into their, or these ionic compounds, they can dissociate into their ions. And of course, we've called this type of solution an electrolyte or electrolytic solution, which means we have free-flowing positive, negative charges. We're going to talk about KSP later. Remember, not all ionic compounds can dissociate and break apart. They might have a very, very small KSP. And in essence, what that means is that their positive, negative charges are stronger in attraction to each other, and the water is not able to dissociate, not able to pull them apart. But basically, that's what we got going on here. Now, of course, if I dried this away, if I took out the water, these guys would reform themselves, some positive and negative charged ions again, which we've all seen before in things such as you wash your car, you wash it with water, the sun dries the water away and it leaves water spots, not water spots. Those are just calcium carbonate spots. Those are ionic crystals that are being left behind.